Everyone is chasing the AI trade. You bought NVIDIA, you bought SoundHound, you bought Palantir, but those are software plays. They are running on classical silicon chips. While these chips are getting faster, we are hitting physical limits. Moore's law is slowing down. For specific classes of unsolvable problems like simulating molecular drugs or cracking encryption, we don't just need faster chips, we need different physics. We need quantum computing. For years, this was science fiction, a toy for Google and IBM labs. But there is a company that stands out as a leading pure-play quantum hardware stock, IonQ, ticker IonQ. They don't use silicon. They use trapped ions, individual atoms, suspended in a vacuum, controlled by lasers, and they are moving fast. In 2025, the company reported hitting a massive technical milestone. #AQ64 algorithmic qubits. The U.S. Air Force Research Lab just awarded them a $54.5 million contract. Is this the Intel of the quantum age? Or is it a hype bubble waiting to burst? Today, we are doing a full deep dive into the quantum hardware monopoly. To understand this stock, you have to understand why scaling is so difficult for competitors like Google and IBM. They primarily use superconducting qubits. Think of their qubits like a cup of coffee sitting on a washing machine. They are man-made circuits. They are prone to noise. They are fragile. To make them work, you have to freeze them to absolute zero, minus 273 degrees Celsius. This is why their computers look like giant gold chandeliers. They are mostly refrigerators. IonQ is different. They use trapped ions. They take a single atom of Ytterbium and soon barium. They zap it with a laser to strip an electron, making it an ion. Then, they use electromagnetic fields to levitate it in a vacuum chamber. Think of table B. The coffee cup is floating in zero gravity. Nothing touches it. Nature makes the qubit. Every atom in the universe is identical. You don't have to manufacture them perfectly. Nature already did. This means IonQ systems can run at room temperature. They are smaller, and crucially, they inherently offer longer coherence times compared to many superconducting approaches. Here is the deep technical alpha that Wall Street misses. For years, IonQ used Ytterbium ions. They worked great, but they required expensive ultraviolet lasers to control. IonQ is quietly transitioning to barium ions. Why does this matter? Barium is visible to standard optical networking gear. It allows them to use cheaper, off-the-shelf telecom fiber optics to network their chips together. This is the key to scaling. Instead of building one giant chip, which is hard, they can build dozens of small chips and connect them with light. This is called reconfigurable multi-core quantum architecture, RMQA. The company's roadmap aims to use this architecture to scale significantly, targeting exponential qubit growth by the end of the decade. In 2024 and 2025, IonQ stopped being just a science project and became a factory. They opened a massive manufacturing facility in Bothell, Washington, Seattle. Before this, every computer was hand-built by PhDs. Now, they are building IonQ Ford Enterprise systems on an assembly line. These systems fit in a standard data center rack. You can slide them right next to an NVIDIA H100 server. This is a manufacturing pivot similar to what we saw with other deep tech firms. And they aren't just selling to researchers anymore. They just signed a deal with NACs to integrate quantum into engineering simulation software. They are working with Hyundai on battery chemistry research. They are moving from science to sales. Let's follow the money. Who is paying for this? First, the Pentagon. The U.S. Air Force Research Lab, AFRL, awarded IonQ a $54.5 million contract in late 2024. Why? Because quantum computing has massive implications for national security. From encryption to materials science, the military needs a domestic champion to develop quantum networking capabilities. IonQ is a key player in that effort. Second, the hyperscalers. IonQ is the only quantum hardware available on Amazon Braket, Microsoft Azure, and Google Cloud simultaneously. They are the arms dealer to the cloud wars. Whether you use AWS or Azure, you are paying IonQ to run the quantum circuit. This cloud access model generates high-margin recurring revenue without IonQ needing to build its own customer support team. Here is the connection most investors miss. Quantum plus AI IonQ is working with partners like Zapata Computing to explore using quantum computers for generative AI. Specifically, they are researching the generation of synthetic data. Imagine you want to train an AI to detect rare financial crashes. You don't have enough real data because these events are rare. IonQ's pilot projects explore using quantum computers to generate synthetic examples to train classical AI models. They are also working with Hyundai on research into object detection for autonomous driving. Early research explored classifying road signs using quantum machine learning (QML). While these are still research pilots, they point to a future where quantum becomes the training gym for advanced AI models. We have to get technical for a minute. How do you measure a quantum computer? It's not just number of qubits. 100 bad qubits are worse than 10 good ones. IonQ emphasizes its own metric, #AQ algorithmic qubits. It measures the useful size of a circuit you can run. They reported hitting #AQ35 in 2024 and #AQ64 in 2025. But their rival, Quantinuum, owned by Honeywell, uses a different metric, quantum volume. Quantinuum claims their systems are superior based on fidelity and connectivity benchmarks. There is an active industry debate over which metric is best. Some critics argue #AQ can be optimized in ways that don't reflect all use cases. As an investor, you should look for independent third-party benchmarks rather than relying solely on company-created metrics. We have to talk about the bear case, and it is ugly. In May 2022, a short-selling firm called Scorpion Capital released a brutal 183-page report. They called IonQ a side hustle and a Ponzi scheme. They claimed the technology didn't work as advertised. The stock crashed while IonQ has since released data, disproving many of these claims and hitting subsequent technical milestones. The shadow remains. Critics still argue that error correction is unsolved, until the industry proves fault tolerance, where the computer fixes its own errors faster than they happen. Quantum computers remain noisy, intermediate-scale quantum NISQ devices. You are betting that the engineering team can solve one of the hardest physics problems in history. How do we value this? You can't use PE ratio. They are losing money. We have to use price to sales. In 2025, they are projecting around $100 million in bookings. With a market cap in the billions, they are trading at a massive multiple. This is a story stock. You are not paying for today's revenue. You are paying for the possibility of a monopoly in 2030. If they hit their long-term revenue targets of $1 billion plus, as forecasted in early SPAC decks, the stock is cheap today. If they get stuck in the science project phase, the valuation is hard to justify. This is a binary bet. It is an option call on the future of physics. IonQ is the purest way to bet on the post-silicon world. They have promising technology-trapped ions. They have strong partners, Amazon, Air Force, but they are fighting against the laws of physics and the ghost of a short report. Are you betting on the atom or staying with the chip? Let me know in the comments. And if you enjoyed this deep dive, check out the KO-Fi link in the description. Remember, this is not financial advice. You're watching Stock Teller, where every ticker has a tail.